we need to show that m plus n raised to the power of 2 over 3 added to m minus n raised to the power of 2 over 3, that's equals to 2 times e raised to the power of 2 third, wherever m and n are given by the following expression. So let's begin. First, we're going to note down whatever is provided to us. So here we have m, which is given by a times cosine cubed theta plus 3a times cosine theta times sine squared theta. And we just let this be equation number 1. And then we have n. So n value is given by a times sine cubed theta plus 3a times cosine squared theta times sine theta. So let this be equation number 2. So first let's do one thing. Let's add equation 1 with equation 2. So that's going to help us find the value of m plus n. So m plus n will be equals to a times cosine cubed theta plus 3a times cosine theta times sine squared theta. So that's the expression on the right hand side of equation 1. This will be added to the expression on the right hand side of equation 2, giving us a times sine cubed theta plus 3a times cosine squared theta times sine theta. In each of the terms, we have a as the common factor. So let's take a as the common factor. And we're going to rewrite each of the terms. So cosine cubed theta can be written as cosine theta whole raised to the power of 3. Plus, we have taken a as the common factor. We're left with 3 cosine theta sine squared theta. So we have 3 times cosine theta times sine squared theta. Now, instead of using the third term, we're going to use the fourth term first. So that will be 3 times cosine squared theta multiplied to sine theta. Plus, we have sine cubed theta, which will be sine theta whole cube. Now, this is actually the expansion of cosine theta plus sine theta whole cube. So let me state it why this is true. Because we know that whenever we have a plus b whole cube, so a plus b whole cube, when you expand it, that becomes a cube plus 3ab squared plus 3a squared b plus b cube. So in that case, we have assumed that a is equivalent to cosine theta and b is equivalent to sine theta. Fine. So this is the value of m plus n. Right? We can actually further simplify this. We're going to divide each side with a. So we have m plus n divided by a. So that's equals to cosine theta plus sine theta whole cube. Now we're going to take the cube root on both sides. Taking the cube root of both sides, we have m plus n over a. So cube root of m plus n over a can be expressed as m plus n divided by a whole raised to the power of 1/3. So this is the value of cosine theta plus sine theta. Now, if we look at our proof, so here we have m plus n raised to the power of 2 over 3. Now we have obtained m plus n raised to the power of 1 over 3. So in order to make it 2 over 3, we're going to square both sides. So let's rewrite the equation. So we have cosine theta plus sine theta. So that's equals to m plus n over a whole raised to the power of 1/3. We're going to square both sides. To get cos theta plus sine theta whole squared equals to m plus n over a whole raised to the power of 2/3. So we're going to label this as equation number 3. Now that we have equation number 3, we're going to set this aside. Now we will take equation number 1, and from it we're going to subtract equation number 2. So we'll do m minus n. So let's do that. 1 minus 2. So that will be m minus n. So we will take a as the common factor before subtracting. We have a multiplied to cosine theta whole cubed plus 3 times cosine theta times sine squared theta minus 3 times cosine squared theta times sine theta minus sine theta whole cube. Now, similarly, as we have done in the previous case, now this time if we take a minus b whole cube, so this will be equivalent to a cubed plus 3ab squared minus 3a squared b minus b cubed. So that means we will now have m minus n, so that will be equals to a times cosine theta minus sine theta whole cube, which means we can rewrite this as cosine theta minus sine theta whole cubed equals to m minus n divided by a. We'll take the cube root on both sides and then square it, and this is going to give us cosine theta minus sine theta whole squared will be equals to m minus n over a whole raised to the power of 2 thirds. So we're going to label this as equation number 4. So using equation 3 and equation 4 and adding them, 3 plus 4. So this is going to give us, on the left hand side we have cosine theta plus sine theta whole squared plus cosine theta minus sine theta whole squared, which will be equals to, we have m plus n over a whole raised to the power of 2 thirds plus m minus n over a whole raised to the power of 2 thirds. So let's expand cosine theta plus sine theta whole squared, which is going to give us cosine squared theta plus sine squared theta plus 2 times sine theta times cosine theta. Plus, we are going to expand cosine theta minus sine theta whole squared to get cosine squared theta plus sine squared theta minus 2 times cosine theta times sine theta, which will be equals to the expression on the right hand side, which is m plus n over a whole raised to the power of 2 thirds plus m minus n divided by a whole raised to the power of 2 thirds. Now here we have 2 times sine theta cosine theta and negative 2 times cosine theta sine theta cancelling out, and cosine theta plus sine theta cosine squared theta plus sine squared theta, that's a standard identity with a value of 1. So 1 plus 1 is going to give us 2. So on the left hand side we have 2, that's equals to m plus n whole raised to the power of 2 thirds divided by a raised to the power of 2 thirds plus m minus n whole raised to the power of 2 thirds divided by a raised to the power of 2 thirds. Now if we multiply both sides with a raised to the power of 2 side, we're going to get 2 times a raised to the power of 2 thirds equals to m plus n whole raised to the power of 2 thirds plus m minus n raised to the power of 2 thirds. Hence we have successfully shown that thus m plus n raised to the power of 2 thirds added to m minus n raised to the power of 2 thirds, that this is equals to 2 times a raised to the power of 2 thirds. Hence proved.